Today we'll be talking about the entity relationship model. So this is chapter 4 for data 16. So about the data model, we want to move from the informal description of what the user wants to accomplish to a precise description of what we will be implementing. So we want to have an exact description of how we will implement the database into the database management system. There are several steps in developing a database. The first step is requirement analysis. That is what the user wants to accomplish. Then we have the conceptual database design. So here we can determine what are the entities and if there are relationships between them. That is, as we discussed last time, we could have an employee and entity, and then department entity where the employee is working, or we could have a customer entity and an order entity, what orders the customer is placing. So we need to, the next step is the logical design to determine the relationships between those entities. That is, the customer places an order, there is a relationship there, or the employee works in a department, so that's another relationship. Once we determine these relationships, we will be creating a schema. The schema would contain the entities and their relationships. Then we will do the physical database design. That is, we're actually going to create these tables in the database, that they will exist physically on the hard drive of the machine. And finally, we'll discuss what these databases are used for, what are their practical applications, and if there is any security steps, security of the database. That is, who is allowed to access the database and what permissions or what permissions do they have, or what actions they're performed to take on the database. So, what are the entities and what are the relationships? The entity relationship model is used for the conceptual design stage, and in here we will determine the entities and the relationships between them. So we need to ask the question, what are the entities in this database and what are the relationships between them? What information about these entities and relationships do we need to store in the database? What are integrity constraints and business rules? So as we mentioned, from the security point of view, certain users would have permissions to log into the database to view certain tables or views of the database. And integrity constraints also have to do with the way the data is being entered, So let's say credit card number is a 16-digit number. So when we're entering credit card, we need to enter an integer with 16 digits. So that is, if we enter something else, the system would generate error. So what is the format for this data, or what is the data type for this field in the database, and who is allowed to use this data to look at it, and for what purpose, what are the business rules. The database schema in the entity relationship model is represented visually, it's a visualization of the database as an entity relationship diagram. And then we can map this diagram into a relational schema. So the entity is a real-world object that is distinguishable from other objects. We say that it's an object because it can really be anything. It could be an employee, a customer that places orders, employee that works on some department, or it can be a patient in a hospital that is taking certain medical treatment. Now these are human entities, the employees, the customers, and the patients. But other than human, it could be anything. This could be a database of computers that make up the computer networks on the internet. Or this could be a database for the climate. So it contains the climate temperatures for certain times of the day for a particular city or location. This could be a database, biological, of the human genes and the human genome. What gene is responsible for what traits in the human or in animals. So that's why we say that the entity really can be anything. Entity can be customer, patient, employee, or it can be temperature. It can be temperature, it can be database of human genes, biological, and it can be database of computers for network. Do you guys have any other suggestion what an entity can be? Can anyone?
Yes, Professor. Bank accounts.
Bank accounts, very good.
Professor, transaction.
Transactions, very good. So they could be transactions when we go to a grocery store and we want to purchase something like bread or milk or fruits, then we create a database of transactions. And anyone else? Yeah, very good. So that's why we call them objects because they can be anything. Now, once we determine what are the entities, we can determine the relationships between them. The entity set would be the set of all entities in or set of similar entities in our database. So for example, employee is an entity, but all the employees would be part of the employee entity set, and those are considered and is a hierarchy. So let's say front desk person is an employee, manager is an employee, customer support representative is an employee. That's an is a relationship. So all of those would be part of the entity set employee. So the key is something else that is important. The key is just a unique identifier for the entity. So let's say if it is an employee, it needs to have an employee ID. ID is an identification, unique identification. So there is a unique number for that employee that is only this employee has, and that's called an ID. Or for example, for a customer or for patient, it can be a social security number. It's gonna be some number or customer ID that is uniquely identifies this entity. So the entity relationship diagram, what does it look like? The major activity that we want to accomplish in this phase is to identify the entities and their relationships, to construct a model, and this model would be called an entity relationship diagram. The entity is represented as a rectangular in terms of the visualization on the diagram. So this is a visual representation of the database. The entity would be pictured as a rectangular, and it's a table because in the relational database the data is in the form of a table, as we explained in the previous lecture. In the table we have rows and columns. The attributes are on the columns. So if there is a customer or a patient or an employee, it will be a column in our relational database that's called customer, patient, or employee. In this case, there is a department here. That's our entity. And then the relationship is represented as a line or an arrow between the two entities that share this relationship. For example, the employee works in a department. Or customer. employee works in customer places order. The relationship line will be a line that connects the two entities. So in this case, the department manages a project. So there is a project entity and department entity. There is a relationship between them because this department works on this project. So department works on project or manages project. There is something called one-to-many or many-to-many relationship, and this can be shown here. As you can see, it says one on the left side, and there is one line here, and on the right side it says many, and there is a circle with 3 lines here. So this means that one department can have one or more projects and or can manage one or more projects. So that is one-to-many relationship. So the entity, as we mentioned, is an object. It can be a person, a place, an item, an event about which we are storing the information, as we already gave some examples, but it can be employee, supplier, a machine tool, an airline seat. And so the object could be a person, a place, item, or event. It can be tangible, such as a human being, a customer, or a product, or it can be intangible, an order that is being placed on a bank account that is being opened. But when we are reading the description from the customer, let's say I want to have a database about my employees, departments they work in, what accounts my clients are creating. We want to read this description, and within the description we have nouns. The nouns will be our objects and entities. And on our entity relationship diagram, the entity is represented with a rectangle like this, and that's a column, one column from our database. And on the top we tell the entity name. So the attribute is a description of the entity, describes or identifies the entity. It is a property of the entity. So the attribute is a descriptor whose values are associated with a particular entity. So let's say the student is our entity. Attribute would be the student ID. That is the descriptors, the descriptions of these students. Student has an ID. Student has a first name and a last name, a date of birth, and a major. So these attributes would describe the student. And to find the attributes, we look for noun phrases or adjectives. The adjectives in the description that the customer is giving us will be describing the entity. So if we look at here, the student entity, its attributes are student ID, first name, last name, date of birth, and major. If we look at the database, these attributes are also columns from the database. So student ID is column 1, so last name is column 2, first name is column 3. In a relational database. Now, how to find the relationship? In the customer description, the relationship will be association between the entities. So, for example, employees are assigned to projects. There is a relationship there. This particular employee works on this particular project. To find the relationships in the description, we would look for verbs. The verbs that connect two or more entities. So these relationships would be represented with a line connecting two or more entities. So, for example, one-to-one relationship, one employee has one employee ID. That is, employee ID is the key for the employee, and only one ID belongs to a particular employee. So that's a one-to-one relationship. One-to-many relationship, many employees could be working on the same project. Or many-to-many relationship, many employees could work on many projects. That is, one employee can have multiple projects, but one project can have multiple employees as well. So that's many-to-many relationship. And this is how we would denote the relationships on the diagram. One-to-one is denoted with a single line. Many relationship would have 3 lines. If it is optional, it will have an O or a circle in front of it. So optional one-to-one, optional many relationship. So the relationship is an association amongst 2 or more entities. For example, Angelina works in a computer department. A set of relationships will be a collection of similar relationships. The way we have a set of entities that's a collection of similar entities, we had a collection of employee entities. In this case, we have a collection of relationships. Here is a data entity relationship model, which is called the Peter Chan notation. Here are the entities are shown as rectangles. Their descriptions are shown as circles. So the student has a name, a major, and an ID number. The professor has a department, a class, and a name. And the relationship is denoted with this diamond shape. Is denoted with a diamond shape. So the student is studying under this professor. That is the relationship between them. The student is studying with this professor, or the student is taking a class with this professor. A student can take many classes, so one-to-many relationship is here. Student can have multiple classes or professors. So this is how the entity relationship diagram looks like. Usually, to implement these relationships, we need, in order to link two tables together, or to in the actual implementation or physical implementation, we need an ID. That's why every student has a student ID, customer has a customer ID, patient has a patient ID. There needs to be a unique identifier. That's our key through which we can link tables. So if you, for example, if the employee works in a particular department, then the employee table would have employee ID, but the department table would also have the employee ID. And because both of them have that, we can link the tables through this attribute. Through the key. So it uniquely identifies an instance of an entity. If there are many keys, we can choose one of them to be the primary key, but it is a unique identifier, so social security number versus name. There could be two or more employees or students with the same name, but the student ID or their employee ID or their social security number is going to be unique or different, even if they have the same name, and that helps us to identify them. So in order to place a constraint about in terms of the integrity constraint that we talked about, we need to define what are the entities, what are the relationships, and if they're one-to-one or one-to-many. So for example, each department has at most one manager. That's a constraint. This means the department to the manager should be one-to-many relationship, and it is as we were seeing here earlier, there is optional one-to-many, but there is a mandatory one-to-many. If we must have at least one manager to each department, that's a constraint, an integrity constraint for our database. We will say this relationship is mandatory, and we would denote it with additional line in front of it. So many-to-many, one-to-many, or many-to-many mandatory relationship. The department has to have a manager. This is a requirement for our organization. So we can place such a constraint on our database, and this would be called an integrity constraint. So for example, every department must appear on an instance of a relationship. That is, employee would work in this particular department. So if every department must have an employee that works in it, we could think, if this is a constraint, is this a participation constraint? This is another example of a participation constraint. So businesses can have certain rules, and when we are implementing the database, we need to follow the business rules that we are given, and the way we would implement those is through constraints. We would put an integrity constraint on our database. Okay, so that is all that we have for entity relationship diagram. There are more slides on this PowerPoint, so please take the time to read through the remaining slides, and the next time we will continue with the relational databases. Implementations.